I wanted to talk about this topic specifically because there's so many different ways of teaching it. So I want to do it consistently throughout all of my little videos here and in my lessons in class. So the first thing I want to do is I want to define percents as a proportion, since we were just doing proportions. So percent by itself basically means out of 100. The per is the out, and the cent means 100, like century or cents. All right, so if it's out of 100 and we have um, like 30%, we can write that as 30 out of 100. Now that is equal to 0.30. Each one of these numbers is equivalent to the one before it. So 30% as a fraction is 30 out of 100. As a decimal, it has a value of 0.3. So the value of each one of these numerically is 0.3. If you have something like 7%, that's the same thing as 7 out of 100. Or if you divide by 100, you get 0.07. So one of the rules that a lot of people are taught, like in middle school and such, is to take the decimal place and move it 2 times to the left. I hate that rule because people move decimals all over the place and generally it goes in the wrong direction. So my rule is this: if you want to change a percent into its decimal value, divide by 100. So decimal, change it to a percent. The directions are going to be divide by 100. Okay. So if you have something like 3/4 of a percent, now if you think about it, 3/4 is smaller than 1, so this better be smaller than 1 out of 100. So the first step is actually to rewrite 3/4 in decimal form. If you do 3 divided by 4 in a calculator, it gives you 0.75. But we have not taken care of the percent yet, so that has to hang out. Alright, to change it to a percent, you write the number 0.75 over 100, and this gives you 0.0075, which is definitely less than 0.01. So 3/4 of the percent has the same value as 0.0075 numerically. Okay, let me add a page in here. So let's say we're going to go the other direction, and this is generally harder. Why? Because it's harder to know when. And here we're talking about change a decimal into a percent. Not all decimals are percents, so we have to be really cautious with this second conversion. So if I know for sure that this number is a percent, then the way to handle it is to take this number. Now notice I'm not writing equals right now, and do the opposite of going from a percent to a decimal, which is take the number, multiply by 100. After you do that, you end up with 8.1. Now that's not saying that 0.081 is the same thing as 8.1. Remember that we have to put in a percent. Then these two numbers are equal to each other. 0.081 has the same numeric value as 8.1%. It's just this side is written as a percent, this side is written as a decimal. But it is harder to know when to do this. To convert a percent into a decimal, oops, wrong way, you have this percent sign here to tell you what to do. It tells you to literally divide by 100. But if you're talking about just a decimal sitting in front of you, it's hard to understand when to change it into a percent. So there's certain values that you know should be a percent. This is the procedure to take you there. Here's a type of percent problem, and this one would be just the basic changing of a ratio into a percent. So if you have a number like 43 out of 90, so for instance, like a test grade, it was a test that was worth 90 points and you got 43 of them. To change that into a percent using a proportion, we would set it up so that we have this 100 here, and any number that we put in the top would represent a percent. So this x literally is x percent because it follows the definition of x out of 100. So this is what's called the proportion setup of a percent. Not always necessary. There's easier ways of doing it, but this one kind of makes sense. And then when I show you the other formula, it'll just kind of fall in line. So to solve this, you could, if you want, to cross multiply, because it is a proportion. But it's easier to say, well, I'm trying to solve for x, I just need to get rid of that 100. So to get rid of the 100, we're just going to multiply both sides by 100. So over here, the hundreds will cancel, and you'll just be left with the variable x, and it's equal to 100 times 43 divided by 90, which comes out to be a 47.8. So what that means is a 43 out of 90, this x is in that top position, it should be written as a percent. So you got 47.8% of the test right. Not a good grade. Alright, so another way of doing this is to recognize what's always going to happen. So if you have a ratio, A over B, and you want to know what percent A is of B, so that's one thing that's going on, you're going to write over here x over 100. So what percent of A is B? I'm sorry, what percent of B is A is the correct way of phrasing it. Alright, so over there we multiplied by 100, so do the same thing. The hundreds again, of course, cancel, and you get a nice formula to find the x percent of a fraction, a ratio, is going to be the fraction times 100, or A divided by B times 100. And that'll tell you the percent of B that gives you A. Okay. Now there's another way of thinking of this. There are old algebra problems like 4 is what percent of 30. These questions have their own little unique setup, and it's not much different than a proportion. It pretty much works out as, or the way I remember it, of is over of is equal to, and I'm going to write it as x out of 100, but technically it's just x percent. Alright, so if you know the number next to is, you put it in the top, so that would be 4. The of is the 30, so of 30, so 30 is equal to x out of 100. So again, we're back to, well, that stuff up there. But then you can ask questions like 4 is 15%, oops, of what number? And then the setup becomes is over of, so we know the is number, that's 4. The of number, well, that's over here, and we're asking what number it is, so that would become, I'll just write n, is equal to 15%, so that would be 15 out of 100. Now with this setup, because the unknown's in the bottom, it's better to cross multiply. So if we cross multiply, we're going to get 400, I'll write that over here. And on this side, I'm going to write 15n, 15 times n. So to find what the number is, the answer would be divide both sides by 15. And you get 400 divided by 15. 26.7. So it's not an exact answer, it's approximate. So n equals 26.7. So that's saying that 4 is 15% of 26.7, or 4 divided by 26.7 times 100 will give you 15%. Alright, so the last video I did, changing a ratio into a percent, and that comes into play with data like this. So this is a group that we studied, and out of that group we separated into men and women, and then the highest degree that they earned was either less than a high school degree, a 2-year degree, or a 4-year degree, or more. So that would include PhDs and graduate work and MBAs and all that kind of stuff. They're all totaled up, so these are the total of less than high school, 2-year, and so forth, and then total men and total women. So when you get a breakdown like this, you can ask, several questions. And some of the more common ones are like, what percent of men had at most a 2-year degree? So when you see a problem like this, you have to focus on what is the main group and what is the subgroup. So here it says what percent of men had at most a 2-year degree. The main group is the men. They're the ones you're concentrating on. So you're going to be looking along the numbers horizontally. And then it says the subgroup is had at most a 2-year degree. So you're going to be looking at 2-year degrees as your secondary group. So when you look at this, you have to say, well, how many of these are out of the main group? So you're going to say how many of the 2-year degrees are out of the main group of men. So I'll put little notes in here. This is the main one. This is the sub one. So it's always going to be the subgroup over the main group, or the total number of what you're looking at over the total number altogether. So this is going to look like the subgroup, 2-year degrees that happen to be men, by the way, so we're talking about 27, and out of all of the men, which would be this 86. Oh. So we're going to use the neat formula which says you can take a ratio and just multiply by 100 to change it into a percent. So once you do that, you can say that this is equal to 27 divided by 86 times 100 gives you 31.4. And just don't forget that this number, to make it equivalent, has to have a percent. So what percent of men had at most a 2-year degree? 31.4% of the men. All right. What about this second one? I'll go to a new screen. What percent of high school degree holders were women? Now the main group here is we're looking out of high school degrees. So here's our main. The subgroup is women. So when we set this up, it's going to be sub over main. So here our main group is high school degrees, so we're looking at this group. And the subgroup in here is the women, so we're looking at, that's our subgroup. Alright, so when we do sub over main, the sub is 25. The main is all of the high school degrees, which happens, to be 55. So that'd be 25 out of 55 times 100, and we're changing it into a percent. So let's see here, 25 divided by 55 times 100. 45.5. So 45.5% of the high school degree holders were women. Okay. So here's the third question. What percent of all, the entire table, all 159, that's a total of everybody, had a 4-year degree or more? So the main group is everyone. So the main group is the 159. The subgroup is the 4-year degree holders or more. So this is your sub. So if we do sub over main, the 4-year degrees holders are these people here. The total number of them is 35, so that would be 35 out of the whole group of 159, times that by 100, change it to a percent. So 35 divided by 159 times 100, 20.0. So this would be about 20%. I'm going to put the 0.0 there just for accuracy. Of this entire table had a 4-year or more degree.